Hello everyone, this is Satvik. Today I am going to represent our project Expression Tracker Sentiment Analysis for Dyslexic Kids. Our project main aim is to enhance the learning experience of the dyslexic children by analyzing the emotions of the children using the deep face model. Now, let's go into the main components of the solution. Front end. Front end is useful to provide a beautiful interface for children and the admin. Children can use this interface to interact with the game, and admin can also use the interface to analyze the result. Middleware, we are using Express.js server. It is used to store the images captured during the gameplay, and it is helpful to communicate between the front end to model, model to server, server to database. Next, we are using CNN model, that is deep face. It is used to analyze the emotions of the children and give a accurate emotion for the image. It is a pre-trained model. Next, database. It is used to store the images details and session data and emotion analysis result for the review and reporting. This is the workflow of our project. At first, child plays the game. During his game, we are going to capture the images. Next, the images are sent to the server using Express.js. Next, images are sent to the deep learning model for analyzing the emotions. After the analysis, the results are sent to the MongoDB and back to the Express.js server. Next, when admin requests for report, he can he can see the emotions of the children. And this is our pictorial representation of our workflow for children and for the admin. This is the technical stack used in our project. In front end, we are using React.js and WebRTC for webcam access. In backend, we are using Node.js, Express.js, and Flask as an API call to the model. CNN model, we are using Deepface library. It is useful to detect the emotions of a child. Database, we are using MongoDB for storing the image details of a child and details of the child like child id, session id, and so on. And it is useful to for real-time updates. Let's go into the data structures we have used in our project. Image data, it stores the path of the image and metadata of each child. Emotion result, it is in the JSON structure holding details of each recognized emotion. Next, user information, it stores the basic information of child like age, child name, session id, and so on. Now we can look into our database schema. For our project, we have a database called Dyslexic and there is a collection called reports. In that, we are going to store the children information such as child name, session ID, session date, and image path and question screenshot path and related metadata of the image. We will store the emotion analysis in a JSON format. Two, if we want to access this data, we can easily access it through by session IDs. If you want a reference, you can see the right side image. For our project, we have two type of roles. One is child and one is therapist. In child role, child has only access to the game where he plays the game and webcam capture his images. For the child role, we have only simple game interface and he has no interaction with the report analysis part. Next is therapist. For therapist, he can access the analysis part and performance. He can view the report of a child and know the emotion state after the gameplay. For therapist, we have a beautiful interface which shows the emotions in a bar graph. For our project, we are going to develop these type of interfaces. For child game, we are going to develop an game interface which captures the images automatically. Next, for admin, in admin interface, we can he can access the reports, analyzes the emotions, and option to reanalysis of stored images. Next, in developer console, in that backend interface for updating the model and monitoring server health, typically accessed through CLI or admin tool. Datasets used in processing. The dataset we have used is pre-trained deep-face model. In that, image capture is done by real-time via webcam sent to the backend with Express.js pre-processing handled by deep face detection, alignment, emotion detection. Deep face classifies emotions such as happiness, sadness, and so on. Data storage, emotion results linked to the game sessions in the database. Processing. Images are passed to the deepface model, which analyzes the facial expressions and return probability of each emotion. The highest emotion among them, along with its score, are stored in the MongoDB. Data collection and sources. Facial expression dataset. Our pre-trained model used FER datasets, which contains uh, emotion such as happy, sad, angry, and so on. In session images, captured images of children playing the game, which are processed in real time or stored for later analysis. These are the input screens of our project. One is for child and one is for admin. In child, you can only access to the game and it does not have access to report part. For admin, he has only access to the report part where he can decide which child you want to see the report. That's it. This is the output screen of our project, which displays the emotions of a child during his gameplay. This is only accessible to the admin. This bar graph shows the emotions of a child in different sessions. It is useful when we are doing a comparison between the sessions. This is the architecture of our project. We have two type of interfaces, child interface and admin interface. In child interface, child is playing the game and during his gameplay, we are capturing his images. After that, images are stored in the server using Express.js. We are also storing the image details and game details in the MongoDB. After that, in admin interface, when admin click on the request button, the images are going to be uploaded to the model. The CNN model will analyze the images and send the emotion result part to the server. From the server, the data obtained must be stored in the MongoDB, and also the data which is come to the server, it is also displayed in the admin interface in visual form such as bar graph and so on. Now, if we look into some key business logic such as emotional based feedback, adjust the game difficulty or show motivational messages if negative emotions are detected, performance tracking scores are based on both gameplay performance and emotional stability, admin reports, periodic report for therapist highlight emotional trends and learning progress of each student, session data retention, rules for storing and managing each session game, including data archiving. Next, reporting logic. Customizable filters for generating reports by time range, emotion type, or other metrics. Error handling and notification. Automated error message and alerts for admin if the model troubles any issues. Now, coming to the conclusion, our project helps us to enhance the educational gaming experience for dyslexic children by detecting emotional states. The system can provide customized feedback and adapt the gameplay to maintain student engagement and motivation. Next steps, model refinement. We continuously refine the AI driven sentiment analysis model to improve accuracy and expand the range of detected emotion. This will enable more responses and interventions. Real world data gathering. Expand the data collection by developing the system in more schools and learning environments. This will provide a robust data set to further train the model and validate the effectiveness. Next, broader educational applications. Explore the potential of the sentiment analysis framework to a wider range of learners, uh, for those with dyslexic across diverse educational settings and subject areas. Sources and reference link. From the below sources, I am able to know about what is deepface, how to install the deepface, what is Moon Stack, and how to use it, what is React.js, Node.js, and all the things I am able to know about. about it by these links. And finally, thank you.